evening, everyone, and welcome to the first community gathering for 2026. Um, Thanks for showing up. We are live on our own Uncast server. We're on Twitch. We're on YouTube. I'm Carl. I'm your host. We've got a couple things to go over tonight. We've got a presentation from Greg, who will be joining us shortly. I wanted to jump in and get a few odds and ends out of the way and just explain what we're doing. So let me jump over and start doing that. So this is our first meeting. I will have better slides next month. I apologize for that up front. That takes us to news and updates. This is the same sort of thing that I give at the Austin RISC-V Summit. Excuse me, not the Austin RISC-V Summit, the Austin RISC-V Meetup. But I will bring it down a little bit for this one, just because a lot of the stuff, I don't know who's here yet. So let me know what's interesting and what's not, and we'll make adjustments accordingly. So news from RISC-V International. There's always good stuff on ISA development and various other odds and ends on the RISC-V journal. I highly recommend checking that out. The big thing that I want to tell you, especially as a chair of one SIG and a vice chair of another SIG, it's early in the year, so check to make sure that your calendar events match the links in the official RISC-V calendar. We've recreated meetings for the new year. That means they have new URLs for getting to Zoom. You don't want to be waiting for a Zoom that doesn't exist or thinking that the meeting's canceled when it isn't. And the only other thing of note is that individual memberships are still disabled. So if you're interested in joining RISC-V as an individual, we're hoping that will be done, fixed later in the year, but we don't have any information right now, which is unfortunate, but here we are. And hey, look, all of the remaining bullet points listed with blanks on them. That's awesome. Something else for me to fix next time. Industry news. There were a lot of mergers and exits in 2025. So just kind of the big ones. Ventana is no more. They are now part of Qualcomm. Revos is no more. They are now part of Meta. MIPS is now part of Global Foundries, but still exists as MIPS. And Esperanto AI, unfortunately, had to close their doors. Their tech was acquired and then later open sourced by Anico, I think is how you pronounce that. I've never actually heard anyone say it, so I'm going to guess that's the correct pronunciation, and maybe I'm wrong. But those were kind of the big industry things that happened last year. 2026 is kind of quiet at the moment, but we're only 14 days in, so maybe it's going to get more interesting. Hardware news, this is kind of the big one. We've anxiously been awaiting these two SoCs, being the Ultra RISC DP1000 and the SpaceMit K3, or SpaceTime K3, excuse me. They were expected to be released in late 2025. They were fabbed, which is good news. We didn't have anything until a couple of weeks ago when my dear friend Weifu announced that they were actually fabbed, but they're stuck in a long packaging queue. So they're waiting to get that done. They're expected to be available in March. For those who are unfamiliar, the Ultra RISC DP1000, it's mostly going to be available as a board called the Milk 5 Titan. Mini ITX board with standard DDR5 SIMs, which is a whole other problem with the world right now, is that we're going to have to buy memory for them. And standard PCI Express slots. It's advertised to be compatible with RVA 22 along with Vector 1.0. Some validation boards are out there, and it seems to be faster than the Sci-Fi Hi-Fi P550 Premier or the Milk 5 MegRes. So that's kind of exciting. Unfortunately, I take that back. It doesn't have Vector. That is a typo. It has the hypervisor extension. It does not have Vector, which is kind of the problem. The SpaceMit K3 is supposed to be full RVA 23. So that means it does have Vector. It does have hypervisor. There's upstreaming work happening underway. There's a bunch of rumored benchmarks that make it to be about on par as the P550 or the MegRes, but it does include Vector 1.0 and Hypervisor 1.0. We have no idea who the initial board partners are going to be. It might be a Pico ITX form factor. I really hope that's not the case. But we do know it's going to have better PCI Express on it, so you should be able to add an external GPU, which is welcome news. Other pieces of information, software news, lots of upstream work in the kernel. The T-Head 1520 SOC now works in mainline. So if you are using a Lychee Pi 4a or the Beagle board Beagle 5 ahead, those both use that sock. You can now use mainline kernels on it, which is fantastic. Other SoCs that are available are the Freedom Unleashed 540, the Freedom Unleashed 570, and the Star 5 JH7110, which is what's in the Vision 5 2, and a bunch of other boards like that. Those all work with upstream vanilla kernels now, which is great. Spacetime K3 stuff is going along, which is exciting. Many submissions to the unsupported Imagination GPU cores. We've talked about this for several months in a few different meetings, but just to catch everyone up, there is a bunch of stuff to get the Imagination GPU cores, which are basically used in all of the RISC-V socks, working. Some of not all of them are supported. There's many variants of it, which is kind of annoying, and there isn't a unified driver space. Right now, the primary focus has been the version of the core that's on the TH1520, and apparently a lot of that work carries over very nicely to the Spacetime K1, but I don't have any definitive information on that yet. I haven't been able to use a vanilla kernel with it to find out. We don't know what's in the K3, so we'll find that out at some point in the future. The reason why they're listed as unsupported is because Imagination lists them as unsupported, yet they're doing the work to make them function. So we're not entirely sure what that means, but it is what it is. Having drivers is better than not having drivers, though, so that is a welcome addition. And there was a lot of great talks related to RISC-V at Linux Plumbers Conference this past December in Tokyo. Definitely recommend checking that out on their YouTube channel. We also have lots of Imagination GPU upstreaming work happening inside of Mesa, which is the major graphics stack inside of Linux, and improvements for Zinc. Zinc is what lets you run GL software on non-GL hardware, and none of the Imagination stuff supports GL. It's all what we call Vulkan first and Vulkan only, much like the Intel Arc graphics series. So Zinc lets you run all of the stuff that is currently using GL and Linux, which is basically everything on that hardware, which is useful. And we're starting to see some speed up of soft pipe stuff inside of Mesa using RISC-V Vector, which is welcome for the people who do not have the ability to change their graphics cards, or if we're having problems getting some of the other Imagination variants working. Last but not least, upcoming events. This is just a small sampling of what's coming this year. But here's the first 3 or 4 months. RISC-V International is going to be at FOSDEM in Brussels, Germany. That is the end of this month and the beginning of next month. World RISC-V Days 2026 is going to be late February. RISC-V International is going to be at Embedded World in Nuremberg, Germany. That will be March 10th through the 12th. I will be at the Southern California Linux Expo, and we have a booth, we being Works with RISC-V. So I'm going to be bringing 3 different machines in order to demo. There will be stickers. After the show, we're going to have a mechanism for people who couldn't make it to the show who want stickers to get stickers. More news on that in March. And I'm looking forward to talking with folks about what can be done and what's working on hardware and what isn't. RISC-V International is working on a booth at Edge AI, which is in San Diego. That's going to be in late March. And they're also going to be at Microelectronics US, which is down the street from me here in Austin, Texas. And that is going to be in late April. We'll update this over the next couple of months. Obviously, all of the stuff from January will fall off in February, and depending on when the meetings are, we'll kind of work through it. But the goal is to give a couple of folks a couple months out interest if you're doing things. I have some other things I'm planning on taking the Works with RISC-V Road Tour to this year. I only have been accepted at scale so far. There are 4 other shows that I'm hoping to go to in North America this year. As I put in those applications and we get yays or nays, I will let folks know what's happening. And I'll probably start posting it on the, definitely post it in the events in Discord. And we'll also post it on the website as time moves on as well. And that's basically it for the upcoming event stuff. With that, I'm going to switch over to introduce our guest Greg from RISC-V International. Greg, how are you today?
I am good. How about yourself?
Excellent. And I can see that we have audio, and that makes me happy.
I figured I'd say something that was non-fully introductory, but yeah, I'm Greg Sterling. I work at RISC-V International, and among other things, I run two programs, which is the RISC-V Dev Boards program, which I'm going to go over first, and then I will go over the RISC-V Ecosystem Lab Partners program, just to give folks like a heads up of kind of what we're doing and give you a sense for if it's interesting to you and how you might be able to get involved. So,
Awesome.
without further ado,
Let me switch over to your
so,
slides.
oops, already switched and was a little too fast.
It's all good. I basically wanted to say hi and introduce you, but we're on our way.
All right, well, I'm a little delayed on the video, so let me know when the slides are up.
You're good. You're up. You're good to go.
All right, all right, all right, cool. So, just a really high level overview. We try to get a number of different folks together from different disciplines between the hardware and software space. So, for the DevBoards program, we get like some firmware folks showing up. Like we talk about bootloaders, what's like the OS platform space. We have people that are interested in working with getting software built, and we're basically just trying to get a medley or a group of just various different disciplines together to talk about RISC-V problems we're having. And it's been awesome to just see people that are like, hey, I have this problem, and then we can help deal with issues cross operating system, or with different GPUs or other things, and really just help build out that educational resource. And Carl's always been great helping out there. He's awesome. So props to Carl. A bit
You
about
flatter
what
me.
we
Thank you.
a bit about what the process looks like is really we try and help identify hardware. So part of the conversations we're trying to have is to understand what RISC-V's hardware is coming out, what is interesting to people and what's not interesting. This isn't really from trying to understand like broad market drivers, but like what is enthusiastically getting the firmware guys looking at stuff, what's exciting them, what problems are they hitting, and similarly like for the operating system space and other folks. So we're just talking about what the hardware is, trying to evaluate what the boards are and how people can use them or get access to them, because the worst thing we want to do is have somebody put in an application for a board and there's not even an operating system level, or it's just too hard to boot and it becomes a doorstop or paperweight for somebody. We're trying to avoid that. So we're really trying to help get the hardware into like the firmware developers' hands, into the core OS, or the Linux, not like the core OS, not core OS itself as a distribution, but we're trying to get into like the OS vendors first, so that we can deliver something that people that are further down the software stack can do to like do. We've had people like apply for doing some interesting like AI drone applications or other things, and that's where we kind of get into the call for submission for projects. So we go through and try and aggregate as best we can to find out what is novel or interesting projects that are somebody is doing, and that will then hopefully feed back into the community. From there, we're looking at trying to review just as best we can what people are doing, like what's been successful or not, and then get these boards out into developers' hands. So if I was to broadly say, we're trying to get it into the earlier people hand for firmware, so we just boot these things. We're trying to get it into the hands of like the GPU, device driver, and other things, and then in the OS space, and then get it out. So it can feel like a very long lead time, but by doing this, we're trying to help make sure things are as successful as possible, so that we come in to do some project check-ins. Folks are like, hey, I was actually able to go build the thing I wanted and everything worked or hit less problems to get through that. We do have some vendors. We don't always fund all of this ourselves. We do have a limited budget, but sometimes vendors do come out and approach us and say like, hey, can you help me get some hardware into different folks out in the ecosystem? And we're absolutely happy to do that. So I don't know what the exact split is, but I'd say it's like 25-30% of hardware that we've been able to get out into people's hands has been through working with vendors that they're like, hey, we got like 10 or 20 or whatever boards. Can we get them out? We'll go run it through the program just like we do for our own budget. Just as a quick overview for what we saw as interesting last year, we had a lot of interest in the Milk 5 Pioneer. people were definitely interested in doing a lot of the scaling clustered kind of deployments that they can. There was some of the backplane management and other things that were of interest. Saw a very large interest in the vector space. So a lot of people were requesting Banana Pi F3s, Orange Pi RV2s, and the Milk 5 Jupiters. Got a lot of interest in that space. That's the majority of what we were able to get out, especially as I'll say economies of scale, but like as basically the boards got reduced in size and got less expensive, it was easier for us to apply um, for buying more boards with the same or less budget, and that allowed us to get more product out into the hands of folks. And we did see a fair bit of interest still in the P550, whether it's the High Five Premier or the Milk 5 Megres. They're just like the applications, people typically looking for either more memory or faster CPU so they could do compute. So we're kind of seeing like just different interests across the board in 2025. Going into what we've been seeing for 2026 and kind of the back half of 2025 for people asking has pretty consistently just been, where's RVA 23? How do I get my hands on RVA 23? But fundamentally, what I think is there's just a cross interest. A lot of teams and folks are looking to get access to both vector and hypervisor, and they want the faster CPUs and more memory. So we've all been through these games before in trying to get as much as you can, but I think we're hitting a very great time where we're going to see a lot of these things getting delivered. So that hopefully we're going to start seeing BMCs where people can do backplane management and do enterprise level rack deployments, be able to manage them consistently, have a hypervisor so that you can run workloads within workloads so you can set up your CI CD and scale appropriately. So we're really excited to see this landing. And for this, we are kind of keeping track on a few different systems. As Carl had said, the space-time K3 is looking like it's going to be a reality pretty soon. We'll have to figure out how do we get access to it? Are we able to purchase it? How do we get it delivered and shipped out? But there's definitely several systems here that we're very interested in and trying to see how they percolate and turn into a reality. And also, do we end up something like we did with have for the Banana Pi F3, Orange Pi RV2, and various other systems where you kind of scale up and down in size, and whether you have GPU capacity, a BMC, or other things. So very interesting time to see where everything's going and how it's all coming together. As far as we've kind of been tracking across different requests, I would say developers we've found are pretty happy with kind of getting the cool newer just bits of technology. It's not always about having the fastest speed. It's sometimes like, hey, I just want to do like really neat vector code optimizations, whether it's with GCC or transcoding or other things. But we tend to see that is a pretty interesting space for the development community. From the platform side, the operating system folks are very frequently asking for rackable, stackable hardware, and we're not really quite there yet. We've worked with some of the teams to discuss like, hey, can we make custom 1U racks where we can mount like ITX, mini ITX or ITX boards in them? But there hasn't really been a vendor that's fully come out and embraced I think like all the different parts and trying to do the latest and greatest thing hasn't quite happened yet, but I think that's going to be something that's going to be very necessary for like the Red Hats, SUSEs, Canonicals, and other companies that want to in-house be able to have this hardware and be able to set up full CI/CD pipelines that are going to match and mimic what they're doing in other architectures. So we're not quite there yet, but hopefully we'll see something in that space this year. And then the labs, I would say they tend to be fairly similar. They overlap with both platform and development quite a bit. The labs that we work with, and I'll get into it a little bit later, but they both want the rackable, stackable deployments, but they're also tend to be very accommodating for taking these like one-off boards that they can get added to their lab so that somebody can come in and use some of these bespoke solutions and have access to try it. So the labs have been really, I'd say, flexible in working in that space. I'm happy to see them kind of taking that mix of different CPUs and technology and getting it deployed. Been really helpful. Um, as far as like just some of like the different places we've sent boards, we've done I've got 3 slides here. I'm not going to like do a deep dive, but we've been really trying to get a good mix across the globe of getting stuff out to academia so that folks have the ability to test out, use, and just experience RISC-V in a space where they might not, they may be getting pushed into other areas normally. Unfortunately, we don't have the budget to go fully fund like a full lab at all of these different institutions because we don't have the budget for it, and it can tend to be quite expensive to do. But where we can help out and facilitate, even if like a professor is reaching out and just says like, "Hey, can you get me 2 or 3 systems or even just 1 so that they can set something up and start playing around with it?" We're absolutely trying to do whatever we can to help accommodate them and get this into the educational system and pipeline because we want more people learning about RISC-V and getting all those fresh ideas that are out there. This isn't the full list of all the platform and operating systems that we've helped enabled, but we do try and work across all of them as best we absolutely can to get them out. I would say by and large, the Linux distros have the most support, but they're also kind of out as a leader in requesting getting access to hardware. And they're also like the most vocal about what works and doesn't work. So that's been great. The FreeBSD, OpenBSD, and some of the other spaces. We're continuing to try and grow those. I would like I've told Carl's probably heard me say a few times I would love to get like FreeBSD or OpenBSD running on like some of the laptops that we've had access to work with or some of the other things because I think all of these things help build out the ecosystem, help find out like edge cases, bugs, and just help enable new people that maybe have specific use cases and needs get access to RISC-V technology. But we're out there. We're really trying to do what we can to help folks out. And then you'll see here, we've got a lot of open source communities, just different software projects that we've been trying to help fund. And as you can imagine, these tend to be a lot of like 1 or 2 boards. But as I said, where we can help folks out working with like getting GPUs enabled, getting network stacks enabled, doing just standard things that you want to do on your desktop, or even like coding tasks using like GCC, Rust, or other things. We're really trying to do whatever we can to at least help people get their foot in the door to be able to enable this stuff so that, as I said, further down the stack, if you want to be building containers or VMs or just raw images, like hopefully like people are getting a better experience on the other side of this. Some of the future directions, if folks, I think everybody's been impacted in one way or another by tariffs, but shipping boards around has become very, very expensive. And with some of as Carl alluded to, some like the sanctions and other things can make it far more complicated to get hardware where we'd like to get it. So we are we're looking at a few things which may reduce the amount of development boards we get in like for the ones off in the community's hands per se, but we're looking at how do we get hardware out that people that are in the community can get access to the hardware or get access to it through like a lab or cloud deployment instead of necessarily having hardware. So we're still going to be getting hardware out as much as we can, but I would say we've found it like whatever the board costs, we typically find that we have to pay double or more because we're trying to do everything we can to get stuff in people's hands by doing like deliver duty paid, paying for taxes, tariffs, and other things. And the last year, we hadn't expected the cost to skyrocket. So to that end, we are trying to continue to get hardware where we can into the operating system platform folks' hands so that they can set up CI/CD or get their foot in the door for doing that, or even if it's just for helping testing specific builds or other things. We're really trying to do that because we believe it's one of the most important things for getting RISC-V working in everybody else's hands. We are going to continue investing in the labs. And as I said, I got some slides coming up, but if you are just looking for access to RISC-V hardware and you don't mind going through a lab, there's a lot of great shared resources, as I've said. So definitely keep that in mind. And we've been doing a lot of really good work with helping enable 10x engineers to get their hardware available to the community through GitHub and GitLab resources. So definitely ask questions if you think that would be useful for you. We're happy to help. And then finally, I have been starting to look into what can we do working with some of the cloud resources so that we can help pay for compute time instead of sending hardware to somebody specifically. It's hard for us to tell when we've invested in sending a board to somebody how much actual like runtime or usage it gets. Some of that you get for free as part of some of the cloud resources and sharing. So as I said, we're investigating that. So we're really looking at a lot of avenues. And if folks have ideas or things are like, hey, could you also consider this? Please reach out. We're open to any and all ideas. We're trying to maximize what we have for a limited budget and get RISC-V exposure to as many people as possible. Just a quick call to action slide here. Broadly, we're really trying to encourage developers and platform folks to get involved in the developer board program. If you want to talk shop and be nerdy, the dev boards program has been a great place, I think, for folks to land. You can talk with Carl if you want a little bit more of a some of the backroom talk about how things are going. But we do really have some good conversations, and it is awesome seeing folks from what would normally be competing distribute like Linux distributions are more than happy to help each other out, deal with problems, and just get things running on RISC-V. Like it's that level of importance and collaboration is great to see. Similarly, if anybody that's out there that happens to either know or be a vendor, if you have access to hardware that you'd like to help donate or can want to have some connection with us to figure out getting it shipped out, we have shipping problems, we've got tariff problems, and we're happy to work with vendors that have access to hardware, whether it's a donation or working with us to figure out how we can do like direct shipment to folks. So that ends the dev board part of the slide deck here. And I just got a few more slides to go over the RISC-V Ecosystem Labs program. So first up, you probably got a good sense for this, but we've been building out this Ecosystem Labs program as a way to provide shared resources and help people get access to hardware through labs. Frequently, what we're finding with a lot of the cloud providers is that they really want a consistent environment. They want consistent platform, which tends to mean that they're not going to be pulling in the latest and greatest. And the labs have been really great to talk with us about what does and does not work, and if we have suggestions on hardware that we think is valuable to get into their system, into their environment. By and large, they're very happy to do it. They're happy to experiment. They have, the folks, whether they're students or interns that are helping work through getting some of the problems done. And in return, they're putting out this hardware out into the world so that if you just sign up for an account, you can get shell or other access to their environment and go run, tests, compiles, or do other workloads on their environment to go see how things work. We do have some different community resources here. So as far as lab partners go, we have 10x engineers, ISCAS, which I always say is PLCT, but we got ISCAS and EPCC. This gives us a mix of what I would say is like 10x and ISCAS are kind of more traditional labs. So it's going to look kind of like a cloud resource frequently, whereas EPCC is a high performance computing lab, and they're doing all kinds of like scaling and other high performance things with RISC-V. So um, we weren't quite sure where the labs program was going to go when we started, and we decided we were going to leave it a little bit more, I don't want to say arbitrary, but a little bit more open for definition. And we're kind of glad we did, because seeing like EPCC or some of the other labs come in that just have different ideas for how to build a lab has been really great to see and be able to help cross communicate with them for the types of problems they're seeing versus like the more traditional labs. We do have a couple candidates right now is open source labs out in Oregon State. And INCHI is also getting involved. So we're getting them kind of continuing them through some of the process for getting certified. And then for some future labs, we've been looking at Hefi, I think it's pronounced Hefi and Dalian. We have some representatives from both of those universities that do attend the labs program as well. They're just starting to kind of learn from the other folks what they need to set up, what does it look like, and how to kind of measure and keep things, make them as consistent as possible. As far as a few highlights last year, definitely a lot of great work to try and help and enable Linux kernels, tests, and build environments. This is something that, if folks don't know, the major Linux distros frequently don't just, they're not just going to say, like, oh, we're going to enable RISC-V. They want to see some of the community effort. They want to see things happening upstream before they would pull it in house. And the labs have been a great resource for being able to enable nodes for various Linux distros so that they can go do builds, they can test things and make sure that it works properly so that they can get their right certification and credentials before it gets pulled in-house. EPCC, as I said, they've been doing a lot of really interesting performance testing for high performance computing environments. 10x engineers, as I'd mentioned already, but I'm going to repeat it again because I think it's just that cool, is they've been doing a lot of work porting GitHub and GitLab runners to RISC-V. And this has been great because one of the things we've seen is a lot of times folks in the development community will say, hey, I want something to go as fast as possible. And they'll go stand up some Intel box or something with, as many cores as they possibly can and as much memory as they can. And then they find out that managing that to run RISC-V isn't quite as fun as they thought it would be, or it's way more work than they expected. And then they start kind of leaning back on, like, what's the easier thing? I just want like some GitHub runners or actions to be able to go through and just tie it into my existing GitHub profiles. So this has been like a lot of really important work to making sure we help enable developers. It may not be the fastest thing, but it's hopefully helping things be more consistent. And then and she's been doing a lot of really great work in China to establish community around their RISC-V lab, helping with education resources and all that. So broadly, we're all working together on this and trying to just put as much of a best foot forward for RISC-V and make things as available for folks as possible. For ways to engage, we do have like just a bunch of different things here. There are resources out there that if you want to go grab the link, you can go check out what we have for the certified labs. The other labs are more than happy to talk with other folks. We do have the email address here. You're more than welcome to send an email and request to help get some connections, or if you have questions on how things work. But we're really just looking to establish as much, whether it's CI, CD testing service resources, making sure that there's sandbox resources there. So yeah, I guess like just please, if you're interested, let us know. And whether you're building a lab or want to use a lab resource, we're happy to help with either. And I guess I'm now at this is the one more slide. I missed it. How to become a RISC-V lab. So we do have a few requirements, but as I said, it's very limited. There's a minimum of 10 boards or 20 cores. Folks need to provide a way for CI testing or doing sandboxing, just like how do you get access to the system and be able to log into it or do things. We do need the web presence, which basically is just describing what your lab is, how to get a account, and what your service options and agreement is, because obviously we don't want people running password crackers or Bitcoin miners on hardware we're trying to get access to the community for doing actual development work. We have participation in the labs meeting is important to make sure that just people know what's going on, and contributing to the lab best practices is just kind of, as I said, we're not really trying to state how the labs should run, but there are some things that we have worked together. So this is a better way typically to do things. And I think with that, I am now on the Q&A slide. So if there are already questions, Carl, let me know and I will do my best to answer them.